Okay, students, now let's talk about factors that influence the conduction of the metallic material or conduction in the metallic materials, not of conduction of electrons in metallic materials. There are basically three factors which influence the conduction in these materials. Number one, temperature. Number two, impurity, the amount of impurity. And number three, defects which are in the form of deformation. Deformation. In order to understand the influence of these three factors, let's talk about the resistivity of the metallic materials. Resistivity of the metallic materials. The first factor is temperature. If I make a plot, here I have temperature increasing from room temperature to higher temperature. On the y-axis, I have the resistivity of the metallic materials. Then, by increasing the temperature, the resistivity of the metallic materials should also increase. By increasing the temperature, the resistivity of this is resistance, not resistance. This is resistance. Resistivity is rho. The resistivity of the metallic materials also increases. Now, question come to our mind: why this is happening? Why this is happening? There are three or four things we should keep in mind before discussing this effect over here. Let me wipe out this thing, and here I can write a few things. Number one, mean free path. Mean free path. Number two, scattering of the electrons. Number three, grain boundaries. Grain boundaries. If we have a perfect metallic material, perfect, then these electrons, when they are moving, they will follow a straight path. They will follow a straight path. But once you increase the temperature, then these ions or atoms which are over here, at low temperature, as I told you, they are vibrating, they are oscillating, they are oscillating around their position. So it is going like this one, here, 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 and there. But when the temperature is low, this oscillation or vibration, atomic vibration, is small. Once you increase this temperature, then atomic vibration will also increase. Which means that electrons now will have to overcome this barrier, because this is a positive charge, this barrier, to go around these ions. Number one, because of the atomic vibration. That is why their mean free path also increases. And when the temperature increases, the scattering of electrons also increases, which means that electrons will also have scattering in between them. And because we don't have a perfect material around us, we have sometimes polycrystalline materials. in them we have grain boundaries. So across those grain boundaries also, these electrons will not follow the straight path. That is why with the increase in the temperature, the resistivity of the metallic materials also increases. So if in the examination I ask a question that list the factors which influence the conductivity in the metallic materials, then you should write temperature, impurity, and deformation. And if I say explain how temperature results into increase in the resistivity, you should say there are three factors: mean free path, scattering, and grain boundaries. When the temperature increases, the values of these things also increases. That is why the resistivity of the metallic materials also increases. Let's mark it as we have a metallic material of copper. So this is for the copper. Second parameter is the impurity. Once you add some amount of impurity in your material, then that impurity also increases the resistivity of the metallic materials, like this one. So this is pure copper. This is copper plus very small amount of nickel added into that. Let's suppose this is 1%. This is copper plus nickel, which is 2%. So once you improve the impurity, add more and more impurity, the resistivity also increases. And once you increase the deformation, this is pure copper without any deformation. And if you add more deformation, then to the resistivity of the materials increases. So this is undeformed copper, this is copper which is deformed, which is deformed. So overall, we can write that the resistivity of the metallic materials, rho T means total, is equal to resistivity due to the temperature, TEMP, plus resistivity due to impurities, IMP, plus resistivity due to deformations. So the total resistivity of the metallic materials is equal to rho temp, rho impurity, rho deformation. And all these factors are combined together to give you a combined number of the resistivity, amount of the resistivity. And in the examination, you should be very careful. If I ask a question, let me repeat, that write the factors that influence the conductivity in the metallic materials, you can write there are three factors that can influence the conductivity in the metallic materials. Number one, temperature. Number two, impurity. And number three, deformations. And if I ask how temperature can increase the resistivity, you can say temperature can increase resistivity based on these three factors: increase in the mean free path, increase in the scattering of electrons, and due to the grain boundaries, there is an increase in the resistivity of the metallic materials. And this plot is given in my PowerPoint, so you can try to understand how this plot is being explained. In my next video, I will explain you the conductivity in the semiconducting materials.